In this video, you will learn how to use GeoGebra to construct a perpendicular to a given line at a given point. On the drawing pad is line AB, labeled as lowercase a, and point C, a point on line AB. We will construct a line perpendicular to line AB that passes through point C. Select the Circle with Center Through Point tool from the Circle toolbar. Click on point C to place the center of the circle at point C, then click on any convenient point to the right of point C on line AB. This creates circle C and point D. Select the New Point tool from the Point toolbar and click on the left intersection of circle C and line AB. This creates point E. Select the Circle with Center Through Point tool again and create a circle centered at point D with a radius longer than that of circle C. This creates circle D and point F. Select the Compass tool from the Circle toolbar. Click the mouse first on point F, then on point D. This creates a circle with the same radius as circle D attached to the cursor. Click on point E to place circle E on the drawing pad centered at point E. Select the New Point tool again and click on the 2 points of intersection of circles D and E. This creates points G and H. Select the Segment Between 2 Points tool from the Line toolbar and create a line segment from point G to point H. This line segment, GH, is perpendicular to line AB at point C. To understand why this is true, create line segments GD, DH, HE, and EG. These line segments are radii of circles that were created using the same compass width. Therefore, GD, DH, HE, and EG are congruent. GDHE is a quadrilateral with 4 congruent sides, so GDHE is a rhombus. The diagonals of a rhombus are perpendicular, so GH is perpendicular to ED and is therefore perpendicular to line AB. Because GeoGebra is dynamic, we can see what happens when we adjust various elements of the construction using the Move tool. Moving points A and B vertically affects the slope of line AB and therefore affects the slope of GH. Notice, however, that GH remains perpendicular to AB. Moving points A and B horizontally affects the scale of the construction. Moving A and B closer together decreases the scale, while moving them away from one another increases the scale. Moving point C along line AB affects the size of circle C, as well as the placement of circles D and E. Notice that if the radius of circle C becomes greater than that of the radius of circle D, circles D and E will no longer intersect. GH. This is why it is important that circle D was created with a longer radius than circle C. Moving point D has a similar effect to point C, as does moving point F. As long as circles D and E intersect and their radii are longer than the radius of circle C, points C, D, and F can be moved to any convenient location on line AB.